All right. Hello, ladies and gentlemen. We're going to talk about acceleration going in a vertical direction, up and down. So what happens when we have, on this planet, we'll have an acceleration and falling. So Galileo figured out all objects have the same rate, independent of mass. And then a little later on, scientists figured out that the gravitational constant is 9.81 meters per second squared. And this is going to be an important value, is that this value here is going to be constant no matter where we are. And we'll talk about that in a minute. And this could be negative 9.81 meters per second squared, depending upon our perspective. Are we watching it go down, or are we going down with this and we think it's positive? So when we talk about Galileo's experiment that the acceleration of gravity is independent of mass, remember Galileo's experiment, he was on a leaning tower of Pisa. So we're going to draw something leaning, and he was on the top. This looks bad, but you get the idea. And here he is standing up here. And he had a couple balls. Now the balls were the same volume. But one was silver, and the other one was gold. So both had the same volume. So basically when we're doing this, we're disregarding or eliminating the effects of air resistance. And so we dropped it. He dropped it about 10 times, and we had some guy on the bottom look and see when they fell and timed how long it took to hit the bottom. And basically had two people with two stopwatches, and they were saying, yes, they hit the same point, and it took this much time. And they changed the volume of the balls, but kept the volume constant between the two, but they changed the size of the balls. And they did another 10 times, and they realized that no matter what the volume was, the volume was the same between both types of balls, silver, gold, or iron, that they both all hit the ground at the same time. So Galileo proved that the gravity had a constant acceleration going down, and no matter what the mass, it was going to be that constant velocity. And with this, it always acts in one direction. So we're on the planet, it's always going to act down. Now, if we're on the moon, it's going to have a higher, different type of acceleration. And I want to point out that we, on average, on our planet, is 9.81 meters per second. This is based on average. Now, it may change as we climb up a mountain. So if we go up a mountain and we're up here, this will be less than 9.81 meters per second. That's because gravity has decreases as we go away from the center of the Earth. As we go down underneath the surface, tunnel down, the gravity is going to increase slightly. The only time where this is a concern when we have to actually have more significant figures in our answer. Right now, everybody uses 9.81. That's going to be considered constant on our planet, despite where we are on the planet. Just want to point out that that may not be true depending on what we're doing. But for the most part, 99% of the time, that's true. Now, I want to show you something. This is one of the talking points we're going to have. So we have a ball, and we're going to give it a velocity going up of 20 meters per second. And we're going to start right here. And we want to know what the velocity of this coming down. And this is going to be, so it's going to go up, stop, and then come back down. So we want to know what's our velocity going down. I'll tell you, give you a hint, it's negative. We start here at 20 meters per second. What's the velocity here going down? And it's going to be negative. So what's going to be the value? Now the answer is, I'm doing this because in case you go wrong, you go back and correct it, is that we'll give it an initial velocity. If it's going down, if we measure it at the same point, it's going to be the same magnitude but opposite direction. So this is going to be minus 20 meters per second. Realize it's going to go up and stop. So it's going to take this much time to go from 20 meters per second to 0. As it's going down, it's going to take the same amount of time to go from here to here. In that case, the velocity when it crosses this point is actually minus 20 meters per second. I hope this all makes sense. If not, please answer. Let me know and we'll discuss it later. All right, so 2 talking points. First one, if a ball is thrown upwards and comes to maximum altitude and comes back down, what's the velocity at this point and what is the acceleration? Well, if it's going to stop and turn around, the velocity should be 0. The acceleration is going to be minus 9.81 meters per second. It's always going to be constant. It's always acting on this ball. So, again, this leads into one of the questions we had last week. When does the instantaneous velocity 0? What is its acceleration? Here's a perfect example. So, 2 kids have a ball. One drops the ball and the other one throws it down with a velocity of 10 meters per second. We want to know what the acceleration is. Remember, velocity acceleration is going to be independent of velocity. So if it starts at 0 and is going down at 9.81 meters per second, or it starts at 10 meters per second, it's still going to go down with the acceleration of gravity, 9.81. Or I should say negative 9.81, and this is a minus 10. So what we have is that no matter what happens, that acceleration is going to be the same. And that's something we need to make sure you're aware of. All right, that's the end of this lecture. Have a nice day, folks.